Hi, welcome to the fourth functions tutorial. Today's tutorial is titled the hyperbola. In today's tutorial we are going to be looking at the basic hyperbola sketch, what it pertains to, and some basic information about the hyperbola. In terms of what you need to know to progress on with this tutorial, you need to be familiar with your grade 10 work. You also need to have gone through the first 3 tutorials on functions. I like to think of the hyperbola as the fraction graph. The hyperbola depicts a relationship whereby as the independent or x variable increases, the dependent or y variable decreases, or vice versa. The standard form we will be looking at for now is y is equals to a over x, or f of x is equals to a over x. Please note that as we progress on with this tutorial and other tutorials in functions, we will expand on this notation. Let us use an example to illustrate this relationship. We are a car manufacturing company, and we are looking at how fast our cars can go. We keep everything constant, that's the engine size and everything else relating to the car except the weight. So we are assuming that the only thing that increases or decreases the speed of the car is the actual weight of the car. And this is the results that we get. By depicting the weight of the car as x and the speed of the car as y, because the speed is dependent on the weight, if x is equals to 2000 kilograms or 2 tons, the maximum speed of the car is 100 kilometers per hour. When the weight of the car is dropped to 1500 kilograms, the maximum speed of the car goes up to 133 kilometers per hour. Drop the weight of the car to 1000 kilograms, the maximum speed goes up to 200 kilometers per hour. And then we drop the weight of the car to 500 kilograms, and the maximum speed of the car is 400 kilometers per hour. This relationship here, if we sketch it on a graph, will look like this. Notice that as x increases, or the weight of the car increases, the speed is lower. Or the other way around, as x decreases, the maximum speed increases. Just a quick note, the equation that depicts the above graph will read y is equals to 200,000 over x, or f of x is equals to 200,000 over x. Let us use another example. This time we are going to start off with the equation. We're going to use the table method to sketch the graph. You will remember having seen something very similar to this in the first tutorial under functions. The example I'm going to use is y is equals to 4 over x. My table is going to look like this. I'm going to start my x values at -3, move them up in integers up to 3, and I'm going to work out my corresponding y values, or f of x values. When x is -3, y is equals to -1.33. When x is equals to -2, y is -2, -1, -4, 0, and undefined. If you try and punch that into your calculator as 4 divided by 0, your calculator is probably going to say math error or undefined. That means that anything divided by 0 is undefined. All we do is we put a mark there, and I'm going to cover that a little bit more when we sketch the graph. When x is equals to 1, y is equals to 4. When x is equals to 2, y is equals to 2, and when x is equals to 3, y is equals to 1.33. If I sketch this on the graph, it's going to look like this. Notice that there's two different graphs. One where x is positive and y is positive, and the other is where x is negative and y is also negative. But at no point do either of them touch 0. This is referred to as the asymptote. These are the parts of the graph that can never be defined. It approaches it, but it is never equals to 0 on either side. I want you to have a go at sketching the next few graphs. Press pause on your DVD player, and when you return, we'll go through it together. The first one I gave you to do read c of x is equal to 3 over x. Now you're going to notice that with these I'm going to try and move away from using the table method. The reason being is just that it's unnecessary to do the table method for everything because it takes too long. C of x is equal to 3 over x, so we know that that's the standard hyperbola graph, which means that it's going to go over there and it's going to go over there. As my x values increase, my y value is going to go lower because my y value, remember, is given by 3 over x, which means that as the denominator goes up, the whole thing goes down. Think about this. 3 over 1 is much smaller than 3 over 8. So as x increases, y decreases, and the converse is true. It cannot ever equal 0. Put that down, state that. X cannot equal 0, and because x cannot equal 0, y cannot equal 0. That means that our two asymptotes, which I'm going to draw in blue, are given as x cannot equal 0 and y cannot equal 0. Now you don't have to draw these asymptotes in if your graph is a standard graph like this. However, I just put it in to show you. If you do want a little more accuracy with your graphs, then you can choose a point and put it in. C of x is equal to 3 over x, so let's choose an x value of 6, which will lead to a corresponding y value of 3 over 6, which is 1 over 2. Alright, like I said, my graph is nowhere near accurate, but just the fact that I've put one point in is sufficient. The second one I gave you to do read d of x is equal to negative 2 over x. The problem with this graph is that we've got a negative over there. Now again, I'm not going to do the full table method. I am going to do some of a table method, or sort of a little bit of table method. Think about this. When my x values are negative, let's just draw my axes over here, x-axis, y-axis. When my x values are negative, let's say for instance a negative x value of, let's go with negative 2. When x is negative 2, dx, or rather y, is going to equal negative 2 over negative 2, which is going to give me positive 1. Let's choose another negative x value. Let's go with negative 1. That means that y is going to equal negative 2 over negative 1, which is positive 2. It's positive 1, that's positive 2. That means that when x is negative 2, y is going to equal positive 1. And when x is negative 1, y is going to equal 2. So that means that my graph is going to be over there. Now let's look at the positive values. Again, we have to say x cannot equal 0, and because of that, y cannot equal 0. State that in. That's our two asymptotes. So I'm not going to put 0 in there. Let's go with 1. When x is equal to 1, y is going to equal negative 2 over 1, which is negative 2. And at 2, y is going to equal negative 1. Notice something, when x is positive 1, y is going to equal negative 2. And when x is equal to 2, y is going to equal negative 1. For this graph here, because my a value, or my numerator, was a negative, the graph is in the opposite two quadrants, because when x is negative, y then becomes positive, and when x is positive, y becomes negative. And this is the graph of d of x. We don't need to label both, just one of the stuff is fine. And if you want to, you can put in a point just to illustrate sort of the shape of it. And the point I'm going to put in is x is equal to 2, y is negative 1. So I'll just write that in over there. And that's sufficient to draw your graph. The next one I gave you to do read e of x is equal to 3 over x minus 1. Haha. This is an interesting one. The problem with this is that my numerator, my x, can equal 0. Sorry, not my numerator, my denominator. X can equal 0, which will make my denominator negative 1. However, my entire denominator, which reads x minus 1, that cannot equal 0, which means that x cannot equal positive 1. Alright? This is my restriction, which means that this is my new asymptote. My new asymptote is x cannot equal positive 1. My other asymptote is that y cannot equal 0. Very simply, that means that 3 over x minus 1 cannot equal 0. So my other asymptote is over there. It's on the x-axis, so we don't need to put it in. That's fine. Now, let's have a look at this. We're working around the values of 1, so I'm going to do a slight table method. I'm going to start off with x values of, let's go with negative 1. Let's go with 0. We know that it cannot equal 1, so I'm going to go with another value of 2. Alright, let's look at our corresponding y values, or e of x values. When x is negative 1, that's going to be negative 1 minus 1, which is negative 2. 3 divided by negative 2 is negative 3 over 2. When x is equal to 0, 0 minus 1 is negative 1. 3 divided by negative 1 is negative 3. When x is equal to 2, 2 minus 1 is 1. 3 divided by 1 is positive 3. Let's sketch those points in. Firstly, when x is equal to negative 1, y is equal to negative 3 over 2. So that's going to be negative 1.5. So that's going to come somewhere over there. When x is equal to 0, y is going to equal negative 3. So that's going to be somewhere over there. So our graph is basically going to look like that. Remember, it's going to approach the asymptote, but it's never going to touch the asymptote. Similarly, when x is equal to 2, that's over there, y is going to equal positive 3, which is over there. And if I work with another value, x is equal to 4, y is going to equal 3 over 4 minus 1, which is 3. 3 over 3 is 1. So, at x is equal to 4, 1, whoops. That's x is equal to 2. X is equal to 4 is going to come somewhere over there. The y value is 1. which means that my graph is going to look something like that. And that's the graph of E of x. Again, if you want to put in a point, you're welcome to. Let's go with the point x is equal to 2, y is equal to 3. We can put that in. Now notice something with this graph over here. It's still the same graph as the previous graph that I was looking at, or the previous graphs, hyperbola graphs that I was looking at, except because of that x minus 1, it means that our asymptote has moved 1 unit in the positive direction, which means that our entire graph has shifted 1 unit in the positive direction. We will cover a bit more of that later on in the next tutorial. Let us take a look at the last one I gave you to do. It read f of x is equal to negative 2 over x plus 2. This is an interesting one. The first restriction I have is that x cannot equal 0. Because x cannot equal 0, that whole thing cannot equal 0, which means that y cannot equal 0 plus 2, which means that y can't equal positive 2. So we have two asymptotes here. The one is x cannot equal 0 and the other is y cannot equal 2. For this one, I'm going to start by drawing a table method. This is my x-axis, this is my y-axis. I am going to start with a table method. I'm going to use x values of negative 2, negative 1. I can't use 0, 1 and 2. My corresponding values, y values, are going to be if x is negative 2, that's negative 2 over negative 2, which is positive 1. Positive 1 plus 2 is equal to positive 3. Negative 2 over negative 1 gives me an answer of positive 2 plus 2 is 4. Negative 2 over 1 is negative 2 plus 2 is 0. Negative 2 over 2 gives me negative 1 plus 2 is positive 1. So an x value of negative 2 will give me a y value of 3. X value of negative 1 will give me a y value of 4. Oh, I forgot to put in my asymptote. My asymptote is that y is equal to 2. My other asymptote is over there, which is fine. When x is equal to 1, y is going to equal 0. When x is equal to 2, y is going to equal positive 1. So basically what's happening is my graph is going to look like that, because my one asymptote is x cannot equal 0, so it will approach 0 but never actually equal it. My other asymptote is at y is equal to 2, so it will approach 2 but never equal it from both directions. And this is my graph f of x. Again, if you want to put in a point, you're welcome to. I'm going to use the point 2 and 1. You can put in any point you want to. If you want to, you don't have to. Notice something, that with this graph here, firstly, it's in the opposite two quadrants as the standard graph. The standard graph looked like that and like that. This one, because of the negative 2, means that it's in the opposite quadrants. At the same time, because of the plus 2, means that it's been shifted up 2 units. Both of these transformations we will cover more in detail in the next few tutorials. Not so bad, is it? Please note that the standard form of the hyperbola equation is y is equals to a over x minus b plus q. In today's tutorial, we only looked at the form y is equals to a over x. I did this because I only wanted to introduce you to the shape of the hyperbola and how it comes about. In the 7th tutorial, titled The Basic Sketch and Transformation, we are going to expand upon this notation. For now though, I want you to have a go at the exercise that I left for you in the workbook before proceeding on with the next tutorial titled The Exponential and Logarithmic Graph.